Okay, on today's session, we are going to discuss about the rolling motion on an inclined plane. So first of all, let's let's just start with rolling motion. So what is a rolling motion? First of all, you know that rolling motion is a combination of both rotational and translational motion. So when there is an object and it is rolling on a surface, it has both rotational motion and also translational motion. Okay, so the rotational motion will be due to the objects, that is the object rotating along its center of mass, and there will be translational motion due to the movement of center of mass, which is the velocity supposed here as vcm. So it will be both combination of rotational motion and translational motion. So the main condition for a rolling motion to occur on a level surface is that the object rolling should not have any slipping. That is, the surface in between the object and the surface, at the point of contact there should not be any relative motion. That is, it should be at momentarily, that is instantaneously at rest. So when we consider a particle on an object which is rolling, so it will have two components. That is due to the translational motion vcm and also the rotational component, which is vr. This will be perpendicular to the radial distance we have taken from the point C. So the net velocity will be the vector sum of the translational component plus the rotational component, and it will be towards this direction. So we can consider 2 points P1 and P2, that is at the two extremes of the point. Okay, suppose this is a disk and there is 2 points P1 and P0 at these two extremes. So we have told earlier that at this point it will be momentarily at rest, which means the net velocity, relative velocity, will be is equal to 0. So as I have said earlier, the particle will have both rotational component of velocity and also translational component of velocity. So when we take the rotational motion along this direction, at this point the velocity will be along the tangential direction, which will be backwards. And also there will be the translational motion, which will be towards the forward direction, which is vcm. And we all know, if the angular velocity is omega, then we can say the velocity at this point v will be is equal to r into omega, where r is the radial distance from the center of the mass in which the object is rotating. So velocity of the center of mass vcm will be r omega. This will be the condition we will get from the point P0, since both are equal and opposite in direction. So their both magnitudes will be equal and it will be same. So this will be the condition for, this is very important, this is the general condition for the pure rolling to occur. For what is the pure rolling to occur? Okay, what is the condition for pure rolling to occur? The first of all, the condition is relative velocity with the object and the ground should be 0. And that when that condition satisfied, the velocity of center of mass vcm will be is equal to r omega. So what about the velocity at this point? We can say the translational motion is towards this direction and also the rotational component along this direction. We have said earlier vcm is equal to r omega and there will be rotational component r omega. So both will add together. At this point the total velocity will be equal to 2r omega, which is as shown here. R omega plus r omega. Okay, so that we have discussed about the conditions for a pure rolling. So there will be two kinetic energies possible. Okay, first due to the translational motion of the center of mass. suppose VCM is the velocity of the center of mass, then the kinetic energy for all the particles which is in the rolling motion, all the particles will have a kinetic energy due to translation motion, which is half mvcm square. And also the rotational component of velocity, kinetic energy k is equal to half I omega square. So I is the moment of inertia. So we can write the moment of inertia I will be equal to mk square, which is shown right here, mk square, where k is the radius of gyration. And we all know the velocity of the center of mass VCM is equal to r omega. So omega will be equal to VCM divided by r, and substituting that value for omega right here, we will get the result right here, that is VCM square divided by r square. So the rotational kinetic energy will be equal to half into mk square VCM square divided by r square. Along with that, we add with the translational component of the velocity, we will get the net kinetic energy will be equal to half mvcm square into 1 plus k square divided by r square. So getting into our main topic of discussion, we have to consider an object which is rolling from a height h of an inclined plane of having a height h, inclined plane having a height h. So we have discussed that the object will have a relative velocity will be equal to 0. The object have relative velocity v is equal to 0. So we can write here as VCM is equal to r omega. So we can say there will not be any relative motion between the object and the surface. There will not be any relative motion between the object and the surface. Hence, there is no relative motion. There won't be any frictional force. That is, the frictional force will be equal to 0. So in this condition, when the object rolls down the inclined plane, we assume the frictional force should be equal to 0. Hence, we can generalize that there will be only conservative forces acting on the object. There will be only conservative forces acting on the object. The conservative forces acting on the object. So we can say the potential energy, change in potential energy is equal to the kinetic energy obtained by the body at this point. We all know the object will have both rotational kinetic energy and translational kinetic energy. Hence, we can say that kinetic energy at the very bottom, which will be equal to half mv square into 1 plus k square divided by r square, which is equal to mgh. As substituting mgh, we will get mgh is equal to half mv square into 1 plus k square divided by r square. So we will get the v square will be equal to 2gh divided by 1 plus k square divided by r square. So for the case of a ring, the radius of gyration k square will be equal to r square. For substituting that values, we will get the velocity of the ring as root 2gh. When substituting that for a disk, which is equal to k square is equal to r square divided by 2, we will get the result as root of 4gh divided by 3. When the radius of gyration k square is equal to 2r square divided by 4 a case of a solid sphere, we will get the velocity as root of 10gh divided by 7. Okay, so that's the case for a velocity of the object. Then we have to consider the acceleration of an inclined plane. So consider the object which is moving towards this direction. So it will have the forces acting on it will be mg sin theta, fs, and also there will be a normal force acting and mg cos theta in the downward direction. So there will be an acceleration A towards this direction due to the translational component of the velocity, and there will be also a rotational component of velocity. So first of all, we are only considering the first condition, we are considering the translational motion. So we can say mg sin theta minus fs is equal to ma. So this will be the force acting on it, and there will be a resisting force acting opposite direction, which is fs. So the net resultant will be an acceleration A towards this direction. So this force will be greater. So we can say mg sin theta minus fs will be equal to m into A. That is, the net force will be equal to mass into acceleration. So getting into the rotational side, we can say this object is rotating. So this is the center of mass. So what will be the tangential force acting on this direction, which will be Fs. So we can say the Fs is creating a torque which causes it to rotate. So we can say Fs will be is equal to torque divided by radius of the object. Radius of the object, as we all know, the force will be, if F is the force and L will be the perpendicular distance, the torque will be F into L. So here is the frictional force, and into the perpendicular distance from the center of mass will be the radius of the object R, which will be is equal to R, which is equal to torque. And for the torque, we have studied the moment of inertia into angular acceleration will be the torque. So substituting that values, we will get mk square alpha, where alpha is the angular acceleration. And substituting for angular acceleration, alpha is equal to a divided by r, we will get mk square a divided by r square for the Fs, which is the frictional force. And substituting that value of frictional force in this equation, we will get the final result. A will be is equal to g sine theta divided by 1 plus k square divided by r square. And in case of the time taken to reach the bottom of the plane, we have to substitute that value, that acceleration we have got here is equal to root of 2h divided by a, and it will be is equal to root of 2h divided by substituting the value of g sine theta into 1 plus k square divided by r square. In this value, we will get root of 2h into 1 plus k square divided by r square whole divided by g sine theta. So, we have discussed the velocity of the object and the condition for pure rolling, and also the time taken to reach the bottom of the plane. So that's all for today's session.